Now you might recognise I'm not Neil. Neil Williams, my colleague, was meant to be giving this training session, but unfortunately for personal reasons he hasn't been able to come to connect this time. Imagine I had a Welsh accent. And you won't be too far wrong. He and I had already been working on the slides for this together, so you should get a vaguely consistent view of where we are in the team. Quick agenda. We've got some background about where we're from, what we've been doing, what Lava is, and where it fits in the bigger CI picture. And then the meat of the presentation is what we see as device requirements for successful automation. I'm going to go through a lot more detail there. And then, obviously, if you have questions, please feel free to dive in. But for the sake of everybody, please wait for a mic. It does help. So, over the 7 years of automation in Linaro, the Lava team have identified a series of failures in automated testing which can be traced back to decisions made when hardware was designed or the firmware was designed to go with it. We have quite a lot of experience. We want to provide some background information about the failures we've seen, the problems it caused, and basically how people could design their hardware and their firmware not necessarily better for their uses, but better for the automated testing, which is what we care about. I'll go into some device design features and a couple of places where we consider things to actually be real hard requirements if you're going to automate your stuff successfully. So, history of Lava. Linaro created the Lava project, 8 years ago, back in 2010, to automate, and the key thing is here, testing of software using real hardware. I'm going to emphasize that is that what we try to do is test the software. The hardware is there to test that. While obviously lots of people want to test hardware using software, that's not been our focus, so it's not what we're focusing on today. Lava is a lovely backronym, stands for the Linaro Automated Validation Architecture. The hardest part of the job for the Lava team and the Lava lab has been integrating new types of device. One of the great things about the ARM ecosystem is there is a huge variability or amount of variation in what people do with their devices. One of the challenges of the ARM ecosystem is there is a huge variation of what people do with their boards. This means that it can be really quite difficult sometimes to come up with a consistent way of testing all of these things. We have seen a number of issues over the years related to hardware design and implementations of firmware. We have run, and I'm sure Dave will back me up on this, millions of test jobs in the various Lava instances that we run in Linaro. We know there are lots of other instances too. It's difficult to know exactly how many they've all run because they don't all tell us. We know it's in the millions total. We've seen over 100 very different types of device. They've been ARM, they've been x86, they've been emulated. We've run PPC stuff in Lava, we've run MIPS things. We don't tend to do those very often because, hell, we're an ARM targeting company, but there's nothing to say we can't support those. We support lots and lots of different primary boot methods, which is U-boot, UEFI, Fastboot, PXE, various different IoT methods. There are others too. We try not to talk about them because they often cause a lot of pain. We currently have over 150 devices in the various instances in the current Task and Lava lab with 40 odd different device types. We checked this when we were doing the session, when we were doing the notes. It's very much a moving target. We also have support in Lava for doing multi-node jobs, so rather than just testing on a single device, we can connect multiple different devices. We can even do complicated things with VLANs in between them. That was interesting work. It's great for some use cases, not everybody needs it. So, the point of Lava is to be part of the CI process. I'm hoping everyone here understands CI. I don't need to go through this in great detail. Does anybody not know what CI means? Awesome. So, of course, we want to be part of this CI loop. Your developers make changes, changes trigger builds, builds trigger tests. We go around in a loop. Hopefully we find out that everything is great. But main thing is we can find out very quickly if developers have made mistakes. That does happen occasionally. We want to minimize the two things. We don't want to see false negatives. When you're checking for that your software works, you want to make sure that you've picked up on the bugs. If you don't have sufficient tests, if you don't have enough test coverage, bugs will slip through. We also don't want to see false positives, and this is a real problem for us. We don't want infrastructure problems to look like there's a problem in the changes you've made in your software. We don't need various other things to cause false positives. False results, full stop, are a problem. So the goals for Lava essentially come down to being a good part of that CI loop. It's only one part of it. We don't pretend to do all of it. We don't pretend to be the only component that can help with testing. Other bits of software are out there now. One of the goals when we started the Lava project, however, was to come up with some good free software that would cover what we needed. Back when we started, there wasn't any, and that was a real problem. Linaro started with a huge amount of kernel work and lots of device enablement and all kinds of good stuff. If you couldn't test it reliably, if you couldn't do automated testing, it's always difficult to know that what you're providing is good quality. So we care about reliability in the CI loop, and of course, what does that mean? It means reliable software. It means reliable infrastructure. It means reliable test devices. If any one of those is not reliable, guess what? Your CI is not reliable. We need scalability of the CI loop. We need lots of devices. We need lots of tests. They've got to run in parallel. If your CI loop does not scale up to meet your needs, things are too slow, developers are sat around waiting for days for a test to run, and after a while they'll give up waiting for you. If you're not scaling to meet the needs of your users, you're not doing useful CI. The flip side of the scalability is it can't cost too much. If you depend on too much expensive hardware, or you need too much expense where admins are forever having to play with devices to recover them or whatever, again, this does not scale. If you have a lot of manual work to make your automation work, well, manual and automation, they're kind of opposites. It's not a good solution. So, we have a few areas where we see device requirements for automation. These are not necessarily hard requirements, but in each place where you miss what we're describing as the requirements or recommendations, in our experience, it will remove your reliability, it will slow you down, it will increase cost. The 3 points I was just talking about. If you can't do good, reliable, scalable, cost-effective CI, there's no point playing. So, reliability. First, a lot of these are truisms, but I'll say them anyway. Your test jobs need to run reliably. Intermittent faults easily consume months of engineering time. We've seen this. False positives reduce the trust of your engineers. If you're telling your engineers that their software is failing, and after a few iterations of looking through the logs and they say, this wasn't my fault, something broke in the lab, something broke on a device, they stop caring. They're not going to be paying attention. If you ask them to fix the bugs that aren't theirs, you've lost their attention.
What would you consider to be an intermittent fault?
Intermittent faults, and I'll point to something actually Milos mentioned in our last session. For example, it's failures of USB serial devices if things interfere. If you've got devices where you can't reliably expect that a USB serial connection will work, then you will end up seeing either corruption or just breakage in the output. If that happens in the middle of a test, your test fails. You can't even necessarily always reliably pick up on those failures and say it's an infrastructure problem. It might just corrupt your output in subtle ways. This is not great.
So typically, if you get an example of a serial failure, you'll get a connection closed rather than serial line corruption. That's less frequent. In which case we will trigger an infrastructure error which the CI front end can pick up and then resubmit. But that's we have ways to work around that sort of issue, but we try and minimise.
Yes. Or other places, if your device does not boot reliably, it can look like it's a failure in the kernel or in the device tree or whatever to boot, instead of the device having just thrown a hissy fit. And again, at that point, it can be really difficult to tell without manual intervention, people reading through logs to try and work out what's failed. Depending on what you're looking for in your tests, it could look identical to the failure you're looking for. It's going to throw you. So, infrastructure failures need to be identified correctly. You know, no one expects infrastructure is ever going to be 100% reliable. It's developed by humans, it's put together, devices fail. So long as you can identify the failures, it's great. But you need to distinguish, and you know, this is all going round the same loop, distinguish between the infrastructure failures and failures of your test. Infrastructure failures need to be minimised. 3 or 4 test job failures a week, and this is not you know, percentage terms. If you have more than that number of failures full stop in your infrastructure, something is probably wrong. It means that people are going to end up wasting time debugging problems. You should expect your infrastructure to work, and again, if you lose confidence in it, your users go away. Devices, you will typically expect, if you're, again, this depends massively on your particular CI setup and what test you're running, but you should expect they're going to be running hundreds and hundreds of test jobs in sequence. You shouldn't have to be playing with a device and going and, say, swapping out SD cards or checking cables or all of those things every 5 jobs. If you do, that's not automation. The other issue that you need to think about is don't let your failures cascade. And again, in LKFT, we've seen this. Problems with USB cables meant that as one test failed, all of the other tests attached to the same dispatcher, attached to the same USB hub, would also fail. They would see resets. So at that point, your scalability has failed because of reliability. And unrelated test jobs are now seeing problems. This is not good. So all of the devices that you're using need to reach this same minimum standard. You can't necessarily automate all devices. That's something we've learned. Not every device is actually ready. Some of them, sometimes we do just have to say, no, we can't do this due to the design, due to the implementation, due to sometimes just production bugs, whatever. However, we can't actually always make everything work. You can't always test all use cases on all possible devices. If the devices are not designed to let you, for example, replace the firmware reliably without manual intervention, without pushing buttons, without having to reseat cables, change jumpers, whatever, then we're not going to be able to automate testing of firmware on those devices. That's just the way the world is. Some people want to, but it's not something that you will be able to do reliably at scale. Thermal conditions and stability under load, we all hate those. if your device is not expected to be run and at its full load, at its full performance all the time, then tests obviously that push those limits are going to cause a device to fail. When you design your devices, please think about that. What we want to come down to is, however, regardless of the type of device, continuous integration as a strategy has to be the same for all of them, regardless of any underlying considerations. Point one, if your CI loop is not reliable, you're wasting your time. So, uniqueness, what do I mean? We expect that every unit that we have connected in the lab should be uniquely identifiable across all of the interfaces that you use. This should be a reasonably simple thing, but you'd be surprised how difficult it is with some devices. If your serial number is the same on every device you've shipped, it's not a serial number, is it? If your Fastboot ID is the same on every device you've shipped, well, no one actually necessarily claims that to be a serial number, but what's the point in having an ID that's not useful for identification? If your MAC address is not unique and stable, you're breaking the rules. You shouldn't, technically you shouldn't ever be connecting that to a network. Yet you'd be you might be amazed, but it's depressing how many devices ship without following the rules for Ethernet, and having a unique, stable MAC address. We can go on and on. There's lots more interfaces. So they also need to be independent of the software that's on the device. The MAC address shouldn't change because you've put a new version of firmware on. It also shouldn't change in between when we see it in firmware and when the kernel comes up. It's breaking the world. Identifiers have to be stable across reboots and test jobs. From one test job to the next, we've got to be able to give consistency. The one thing that people expect when they're giving us their test jobs is that we're providing a reliable, stable, consistent platform to test the software. If the world underneath is changing, it's very difficult for us to provide any kind of stability here. USB serial connectors are the bane of our life. Everyone who's ever done any time testing with modern boards will have seen USB serial devices that all look the same. So you plug in one board into your laptop and it's fine. Plug in 2, which one are you talking to? Plug in 5 or 500 into a complicated chain in a lab, and now imagine I've turned a device on, I need to be looking at the serial output to see what's going on, I need to be looking at kernel messages. Which device are you talking to? Stability here with unique addressability is really, really important. And MAC addresses, I've already ranted about. I used to do networking for a living. It was seen as target number 1 was you must make sure this works. And if you didn't, well, product never shipped. But dev boards apparently are different. Dave, you look like you're about to interject.
No, I was about to just say about the USB serial connectors. Far too often, people go, oh, but it works on my laptop. I just know it's /dev/tty USB 1. That doesn't help when you've got hundreds of devices. If it does not uniquely identify in dev serial by ID, then we have a problem.
Yeah, absolutely.
A question?
Yeah.
What does Lava use device identifiers for?
So in a few places, networking, MAC addresses, obviously, when things boot, We need to be able to give them, sensible IP addresses. We need to be able to identify which interface we're talking to on devices with multiple network interfaces, for example, so we know where packets are being routed, that kind of thing. For serial identifiers, we need to make sure that when a device appears, because we've just turned it on, that
so
we
you're
have...
saying that Lava can't use topology knowledge. It actually, for automation, you have to use identifiers.
Yes, topology can help, but topology can also shift far too readily.
Mm-hmm.
Part of adminning a lab can also involve rebalancing devices, moving them around. We want to be able to identify the devices using the uniqueness that is meant to be there already. Having to store the topology for everything is a possibility, but it's much harder.
And in a lot of cases, in a lot of cases with MAC addresses, we want to fix the IP address of that device every time it boots up, because Lava itself, test writers, want to be able to talk to the device under test from a container, and they have to be able to pick up the IP address. They don't want to have to go query our DHCP servers.
For example, if people wanting to log in and talk to a device using almost any connectivity, whether it's serial, whether it's IP, or anything like that, the only sane way to make this work reliably across all devices is to follow the rules that are already published and make things unique, make things stable.
Now, in certain cases with USB serial, we have our own way of solving that problem, because we buy FTDI cables which uniquely identify themselves.
Yeah.
But not all boards provide that sort of level.
Steve, Maria.
And it is very important to identify the fact that if you have devices that do Fastboot and you make firmware updates that changes that serial number, it will make our life incredibly hard. If you, for instance, change it so that all the serial number are question marks, test won't work. And you won't know which one of all the question marks will be the device that you actually want to use.
Exactly, that comes back to devices that have been tested or expected to be used connected to a developer laptop, but not tested at scale in a lab where there could be, and I'm not exaggerating, 100 or 1,000 of these devices all connected at once, all running independent tests. If you cannot uniquely identify the device you're trying to test on, you've lost. So, scalability. We are aiming to have a homogeneous test platform, big words, using heterogeneous devices. We need to have scalable infrastructure to do that. We want to be able to support testing 100, 200, 1,000 different types of device with 1, 10, 100, 1,000 of each of those devices. This is important. We don't know exactly how any given test lab is going to be set up. Some of them out there are going to have one type of device and hundreds of them. Some labs may have hundreds of device types and only one of them. Scalability either way matters. So the thing to do in terms of the device design here is keep it simple. Try to avoid extra customized hardware if you can. If you want to be plugging into a lab alongside 100 other device types, please, for the sake of the people running that lab, make your device look reasonably similar to the other devices. Use standard connectors. Use standard things that don't need special knowledge, don't need to have lots and lots of special treatment. The special snowflakes of this world just make life harder for everybody involved. If you need to have things like relays, or if we have to modify the hardware or attach mezzanine boards to be able to talk to it, this is extra complication, this is extra effort needed in initial setup. When we come to debug problems on these boards, it's more it's more admin effort needed there too.
So I'll just make a comment about that. We do occasionally deploy with relays. And for some boards it's easier than for others. For some boards we've just got jumpers that we can use the relays to, the jumper pins to short them out. Other boards have got dip switches or require the push of a button, and there's nothing there that we can just hook onto, so we have to end up doing soldering modifications, and that does not scale.
Yeah. You know, essentially, you don't want the lab people to have to be using soldering irons. You know, they're competent engineering people, but still, the more you have to get them to do the work on your boards to be able to use them at all, the more likely it is that your board will be damaged. Not necessarily intentionally, you know, we're not like that, but mistakes happen. The more people have to physically modify boards, the greater the chance that modifications will cause problems.
And there is another point of failure.
Yeah, it's another point of failure. More complexity raises failure risk. We know this. The harder it is to work with boards, the harder it is to work with boards even more so.
I've got an example which I'm working on at the moment, which is putting a high key into recovery mode so to allow lava to reflash the low-level bootloader if you've completely pricked the board. 90 times, sorry, I to say 9 times out of 10, that flip using the relay works. And sometimes it doesn't. And that means we're not guaranteed high reliability. 10% is a fairly high failure rate.
So we're not just talking hardware as well. If your device depends on unreliable protocols and connections, Wi-Fi and Bluetooth are like this. It's massively more likely that you're going to see problems.
That said, IoT, that's the way we're going to have to do it. So.
But again, this comes down to testing, and it's all about single device as opposed to thousands of devices. If your device works fine in your, on your desk in a nice, quiet office somewhere, where you might just see a couple of access points, and the access point you're using here is right next door, then fine, it'll be absolutely reliable for firmware updates. Now imagine that in a busy, noisy, really packed lab with 1,000 other devices, potentially in the middle of a data center with 2 dozen, 3 dozen APs, and now you want to have 100 of your devices all update. Because they're all running independent tests, you now want to have 100 of your devices all update in parallel over a dodgy Wi-Fi connection. Can you imagine how well that works? So we're not demanding enterprise or server grade support here, because we've had this accusation in the past that, but we're not trying to test a server product. All we want to do, this is a phone, or this is something equally, it's a dev board. This, we can't guarantee reliability, but automation can't scale if the hardware is not reliable. Server support typically includes things, automation requirements as a subset. We have RAS. We have to think about performance, efficiency, scalability, reliability, all of those. We are providing, essentially, in the Linaro lab, and hopefully in other labs, we're trying to provide an enterprise level service here. If the components underneath that service are not reliable, they're not fit for purpose. And it's a hard fact. Again, this comes back to, we acknowledge not every device is fit for full-scale, reliable, 24/7, service like this. In those situations, we don't want to automate those devices. And it's a hard thing to admit, but that's the way of the world. So automation racks basically have the same requirements as data centers. They've got to work reliably at scale. Our lab in Harston has, 20 racks?
Yeah.
20 racks full of equipment. We expect any given test device, any given switch, any given server involved to work reliably for months on end without intervention. If it doesn't, it's a failure. We do have a lab team of 3 people who are already over busy going in there, adding more machinery, removing old devices, doing firmware upgrades and all kinds of stuff. The more they have to intervene with devices that are just not reliable, the worse the service is for everybody.
Yeah, just on that point. So, what I was saying, where 9 times out of 10 I get into recovery mode, and I get into recovery mode, and 1 time out of 10 it doesn't. That is also true if you just put a jumper across it, by the way. You have to reboot and it will eventually come back into recovery mode. But when you're just doing that on your desktop and it doesn't show up, you go, I'll just reboot the board, and it comes back. In an automated environment,
It doesn't work.
No.
So the last part that we have to consider is deployment. To be able to test the software on the boards, we have to have a reliable, automatable, scalable method for deploying and booting and testing software on the board. So lots of the things we do, we will deploy over the network using TFTP. TFTP is awesome. It's a well understood technology that goes back 30-something years. I don't pretend to know when it started. There's a reason why it's still around, is because it works and people understand it. It's not the best protocol in the world, but it's very, very simple. It's easy to get right, and therefore people do. Manually writing software to SD, and for example, putting things onto an SD card, going and put it into your device, reboot it, is not an automation solution. That's the testing on a device on your desk answer. You can see the difference there. If we have to go fighting with SD cards to test things in a lab, we will throw those devices away. They're not going to work for us.
I mean, to some extent, we have devices that boot from SD and that we can change SDs for if we need an updated firmware. But then we're just testing everything that is after that. We will never be testing what is actually on the SD.
Yeah, absolutely. We need to be able to deploy the software that we're testing for you easily, reliably, reasonably quickly. If it takes a week, it's not very helpful. But we've got to do it reliably, scalably, all of those good things. If we can't, again, the device is no use. You've always got to be able to interrupt a device at a level lower than what you're testing. This is something that people actually often struggle with. If your device boots U-boot, and then we're testing the Linux kernel and software running on top of it, that's great. We can talk to U-boot reliably, we can get in there, we can tell it to boot over TFTP. However we get it to boot, it's great. If, however, the first chance we get on the board to talk to it is by interrupting U-boot, we cannot reliably test U-boot on that device. Because, fairly obviously, I hope, please, if you haven't thought this through, we'll talk about it afterwards. If the new version of U-boot you are writing to your device does not work, and by does not work, for whatever reason it doesn't boot, your device is dead. It's bricked. We can't get to it anymore to be able to go back to a known good version. That is not testable in an automated fashion. Even if you think, oh, it's not a problem, we don't make that kind of mistake. It'll always come up, and 99% of the time it'll be fine. That 1% causes your pain, and the 1% turns into 5% or 10%, and this is, of course, the problem that we see. It's the cascading failures. If you have a 1% failure rate on something that bricks a device, it won't take very long for you to brick all of the devices when you deploy something broken. And then your lab is on fire and your admins are screaming at you and what have you done and why, and not because they don't like you, but because they're being screamed at by other users who want to test their software too. You have to think about these things. If you want to be able to test low-level firmware, you need to be able to interrupt and replace that firmware at a lower level again. So actually consider adding a BMC if you can. Now I appreciate a BMC on a really small test device is expensive, it's not something you're going to do, but there's a reason why people put BMCs on servers. So they can do this, regardless of what the server's done, they can always get in. Automation typically requires controlling the device over serial. We are not going to be able to have something that drives it with a touch screen. While people like to have fantasies of, yes, we could have a robot that pushes the right thing on the screen at the right time. No, please don't go there. Simple, clean serial connections are the way that we test things. If you have something that needs to interact with graphical menus, even over a serial port, that makes things harder. Please don't. Give us a nice simple command line we can interact with. It's not impossible to automate driving menus, but it's really hard. It makes your device a special snowflake. Don't do that. Because your device's menus will look different to the next device's menus. Or the version with the next version of firmware, some clever person will have added a new menu entry, and suddenly all of our tests fail because it doesn't automate in the same way. Please avoid that. Now, you might not be able to automate the lower levels of a device, but that's not always a problem. For example, the way that we often test UEFI devices in the lab is we netboot grub. From grub, we can go and netboot a kernel, and if the kernel is what you're testing, that's perfectly fine. If you're wanting to test lower stuff that is lower down, think about how you're going to replace it, as I was saying earlier. Finally, and this is actually possibly the most important thing here, consider how your deployment tools interact. ADB is an awesome tool. It's great. It does lots and lots of things. It can talk to all the devices that are connected to your machine at once, and it's lovely. Now imagine in the lab, again, we have 100 devices. ADB starts up and basically blocks all of those devices. We've spent a lot of time and effort working around tools like ADB and Fastboot doing this, so we can sensibly, independently interact with all of those test devices. If your deployment tool is designed for use on a desk, and it goes and probes and automatically picks up all the devices attached, that's actually a good hint it's not designed for automation, for exactly that reason. Scaling and not interacting badly with other copies of the same deployment tool is really important for us. So, basic recommendations to consider during your hardware design, your firmware design, and overall. These are not hard and fast rules. You know, we're not going to come and hunt you down and shoot you if you do this wrong. But we might have problems. We might tell you afterwards that if you don't think about these things, your device is not going to go in the lava lab easily, or at all. We know every device is different. Not every device is destined to be automated. Again, I know I'm repeating myself, apologies if I'm getting boring. We do acknowledge this, not every device is going to be automated. Some of the device manufacturers, however, struggle to understand this in return. If you want to automate things, there are some obvious ideas, and there are some that you only pick up after you've fought with a couple of hundred different devices and you know the patterns for the bad ones.
Just going back to the deployment tool thing, also please provide us with a Linux tool.
Oh, absolutely, yes. If your tool for deployment means that you need to spin up a Windows VM, we are not going to do that.
We've tried in the past, it didn't go well.
Yeah. So, production hardware is often not suitable for automation. Again, this is something that might not be obvious. Typically, your production hardware will have connectivity removed, or it will have features on it that are not actually fit for automation because it's not designed for it. Ryan?
They'll also be hazardous, like phones blow
Yeah, exactly. Batteries. I'm coming to batteries is a real feature that we have to worry about. But for example, in my previous job, I worked for a company, and I'm going to admit it on camera, I've worked on set-top boxes in the past. The devices that we shipped to customers had to be locked down for the sake of DRM. They had to have no serial ports, for example. That meant that our own devices that were shipped from the factory were no use to us for our own automated testing. We had to have our own separate build of devices with different features enabled, which always meant that we had fun and we weren't actually doing the release testing on the devices we were shipping, but sometimes that's the only way around. And again, testing will typically work differently to what your customer is thinking of. We're going to be stressing different interfaces and different methods on your hardware. We may break all your assumptions. You know, you think you're designing a phone that's going to be running out, you're designing a CPU and a board that's going to go in a phone and run Android. We're looking at a board that we're going to thrash like crazy using, probably not Android, it might even be OE, that we're downloading all the time and booting Linux, thrashing it hard, doing kernel CI testing or something, and we want to see what performance looks like under load, and it doesn't look anything like the board that you think you've shipped. Think about that when you ask us, can we put these devices into lava?
But still, even if you think about that, there are quite often workarounds. As for batteries, for an instance, last week
I'm coming to it.
Yeah.
So, hardware design for automation, absolutely top thing. Keep it simple. I'm not going to add the extra S word on the end, I don't need to. Serial ports. Either put real serial ports on, or add good USB serial. And you know what we mean by good USB serial? Stuff that works. Stuff that's unique.
And that doesn't go away.
And stuff that doesn't go away when you power your board off. Absolutely the right answer for USB serial is to have it be powered by the host, not the device. If it's powered by your device, it goes away. In the middle of a test, at the point when we apply power, or take power away, or whatever, suddenly we lose all the connections to the device. We have a problem then finding it when it does reappear, and potentially it's not got the same ID, and then we might miss the first few characters that are coming out that are key to your test, depending on what we're doing. Please do it right. Remote power control is important to us. The main way that we test devices, the main way we control them is we yank power out, we apply power. Batteries are a problem here, they're a real problem. If you end up with a battery on your device and that is primary power for it, we can't just unplug power. If you have a battery on it that only charges in certain operating modes, then your device might suddenly stop because it doesn't have power in the middle of a test. Or even worse, as Ryan alluded to, your battery might charge too much or might discharge too rapidly and bulge, burst, explode. Please, we don't like fires in the lab, this is bad. We also want to have immediate power, immediate boot when we apply power. If we have to push buttons, if we have to fight with a battery, this is more complexity. Please, and again, this is not necessarily what you want for a customer-facing device, but if you want something that is going to work in an automated testing solution, have it boot the moment you apply power. It's the right answer. Standard interfaces and form factors are a good plan. Please use normal physical connections. Use RJ45, use USB. Don't need a custom connection to get one of those. Don't make us need adapters, because those are the things that will be fragile. Those are the things that will get lost. Those are the things that make your board harder to work with. Electrical specifications, please use a standard power connector. Use a standard power supply. Don't need 11.5 volts, and don't fail if we give you 12. Don't do weird and wonderful things. The easier you can make it for us to use your board, the better we'll like you the better it's going to work in our system. Equally, things like standard interfaces and form factors, if your board is the right shape and will go in a standard case, oh, that makes life so much easier. If it will fit on a rack easily, it is so much easier. For onboard networking, please do physical Ethernet if you want us to drive it. Again, this is not what a lot of devices come with. If we want to be testing reliably, we want to be able to plug our normal cables in and have it just work. We can work around, but every workaround adds more effort, more cost. Storage reliability matters. If you're putting, and again, cost constraints are important for a lot of devices, we totally understand that. But if you have really cheap and nasty eMMC or something on your device that fails after we've been using it as a test device for 4 months, admittedly thrashing it, nothing like your customers are going to, then it means for our uses, it's not worth having. So either very reliable storage or even removable storage that we can then actually put micro SD cards in or whatever instead. Protect the essential components. Things like heat sinks are not a bad plan. Again, you might not want them for your shipping devices. Make it easy for us to make your device last longer. Don't have protruding elements that make it really, really easy for it to get knocked and damaged in the lab. Again, imagine, because I've seen this, I've done this, you've got 2 people working in the rack where your device is, on the machine, above it, below it, next to it, and if you have protruding cables, protruding adapters, whatever, that make it easier for your machine to be knocked or damaged, it will be knocked and damaged.
Also, think about your lab admin when you're putting heat sinks and the SIM on so that we don't go and burn our fingers, because that's quite painful.
And lastly, and this is again a real tension between what you're shipping for your customers and hopefully doing really well at and selling millions of, that's great. You want to absolutely minimize the cost per board. If you minimize the cost per board so far, you've taken all the cost out and made a board not that reliable or really hard to work on for us, we're going to hate you for it. Well, we're not going to hate you for it, but we're not going to like working with your hardware. It is going to be harder for us. It's not going to go well. So, firmware design for automation. Please adopt existing solutions where they exist. That makes it easier to work with the device. If you have your own special needs in the firmware, then you may have those, but it won't make it easy for us to work with it. Please, absolutely, don't write your own firmware. So many people think they have to do this. So it's not firmware, bootloader. Do not write your own bootloader. It's like, don't write your own crypto code. You might think you have a compelling reason. I 99.9% guarantee you don't. You just don't understand the problem. If you write your own bootloader, it makes it so much harder to automate your device that this is the hardest part of what we have to do when we're working with something new. Please don't. Do, however, make it robust against mistakes. Don't depend on settings written in Flash. Or don't panic. Don't depend totally on those settings. Allow us to recover from problems. If you have settings in Flash that will cause your device to brick, make it easy for us to get in, to get back. Serial support is great. Please have your firmware talk serial. That way we can see what it's doing. If we have a device that seems to do nothing for the first 2 minutes of its life, we are not going to know if your device is alive, dead, or whatever. Please make it easy for us. Ensure that connectivity is available in the firmware. If you have Ethernet on board and your firmware can't talk to it, it may as well not be there. Make sure that your bootloader and your firmware can talk to the storage. Then that way, we can use it. This is all simple stuff, I hope. Consider chain loading, as I mentioned earlier. Don't necessarily assume that your first level firmware has to be the thing we're talking to. We're okay talking 2 or 3 levels later on, so long as something is reliable. So by all means, your first level firmware can be really simple. If it then later comes up and we see U-boot or grub, we're happy. And I'm repeating myself again now, but these are recommendations. Make sure that all of your interfaces have stable, unique, reliable identifiers. And make sure that all of your settings are stable and have consistent meaning across, say, different firmware versions and whatever. If a setting in firmware version 3 says don't do something, and then in firmware version 8 now means the exact opposite, that makes it really, really hard for us to deal with your devices. We then have to go through and do manual intervention on every device as we do firmware updates, above and beyond what we actually want to have to do. Please don't. Then overall design this thing for testing. Not just the testing as it comes off the line, but the testing that we're aiming for. After all, we're trying to test software, not the hardware here. We need to think about that. Consider reliability from the beginning. In all of these places that I've spoken about, like your choice of components, like heat sinks, all of that, please think about how your device is going to work over lots of cycles of testing over an extended period. If you're expecting your device will not survive 6 months in a harsh lab environment, to be honest, we'd rather not see your device. It's not helpful for us, it's not helpful for you. Avoid the not invented here syndrome. Try to avoid custom tools. If you have tools that you need to flash new software on your device, use the standard ones that are out there already. And if you are using the standard ones and you've got patches that you need to apply to those standard tools, make sure they go upstream. We don't want to have to go work with your password protected special Git repo for your one device to get a version of a flashing tool where frankly it should be in the standard version, but for some reason you haven't made it. Again, this is all extra effort that we don't want to have to do. Nobody wants. Consider adding a BMC. Again, it's expensive. It depends on your device. Finally, consider how people are going to use your hardware. And this is not just your end user customers. This is, for us, your device, regardless of what it looks like, is going to be thrashed to hell and back, is going to be running 24/7, is going to be absolutely worked very hard, possibly doing things that are very different, totally different software to your original use case for the hardware. Think about those. We want to work with you. We would love to see more good devices in the lab. Now, that's about it for where I wanted to get to, and wow, we are 2 minutes off time. If you want more information about Lava, we have a lot of docs. We like to think we cover most of what people need. We appreciate Lava is a big, complicated system. We don't have everything covered. Please, if there are things that are not clear, ask us on our mailing list and whatever, and we will do what we can to help. So, thank you for coming. I think we have time for maybe 1 or 2 questions.
We don't. Bill has to set up.
Apparently, no, we don't. Bill has to set up. So,
He's in the room if need be.
yeah, so we're all going to be around in the room for the next couple of sessions as Bill does more bits of Lava training. Please grab me or any of the other Lava team members or the lab team members. You know, if you have any more questions, we would like to work with you more, and this is the whole point of this kind of presentation. So, thank you for coming, folks.